Hello everyone. In this video, I will give an explanation for basic vectors. There will be more videos about vectors after this one. This is just an introduction. So, a vector has both magnitude and direction. A scalar has only magnitude. Examples of scalars are temperature, pressure, speed, distance, time, density. Scalars are just a number, a value, without direction. Examples of vector is force, velocity, displacement, acceleration, impulse, and momentum. So anything with a magnitude and direction. Velocity, for example, the magnitude of velocity is the speed. And the direction of the velocity is north, south, and so forth, degrees, blah, blah, blah. Alright, so examples of a vector. We have in this example a 10 newtons force at 22 degrees from the positive x-axis. The horizontal component of this vector will be 10 cosine of 22, which gives us 9.27 newtons. The vertical component is 10 sine of 22, which gives you 3.75 newtons. As a good physicist, you should be always skeptical of your answers. So it's always good to check to see if it's correct. So if you do the square root of 9.27 squared plus 3.75 squared, you do get 10. Because, you know, the sine gives you the y component of this right triangle. And the x gives you the the horizontal component of this right triangle. So the net force, the 10 newtons, will be the hypotenuse of that triangle. That proves that we got the components correctly. And inverse of tangent of 3.75 divided by 9.27 will give you 22 degrees, which also checks as our previous answer. 22 degrees is the angle from the x-axis. Tangent is opposite of adjacent. So when you do the inverse tangent of opposite of adjacent, you should get the angle facing those two sides. Adding vectors. Imagine a particle under the influence of four forces as shown. 1 Newton up, 3 Newton to the right, 2 Newton down, and 1 Newton left. So the goal here is to find what the net force in this particle will be. Well, the 3 newtons to the right is in the x, 3 positive. The 1 newton to the left is negative in the x. The 1 newton pointing to the top is positive 1 in the y, and the 2 down is negative 2 in the y. So what I'm doing here is I'm summing up the x's, I'm summing up the y's, to get a total. So 3 minus 1, 2 to the right. 1 minus 2, 1 towards the downward direction. And then we're going to draw the net vector in the particle. Always start with the x-axis first. 2 to the right, from here, 1 down. So when you do the hypotenuse of this triangle, square root of 2 squared plus 1 squared gives you 2.24 newtons. And the direction will be this angle here, which can be found by doing the inverse tangent of 1 over 2, which is negative 27 degrees. The inverse tangent will give you positive 27, but we know it has to be negative because it's below the x-axis. So the final answer is net force is 2.24 newtons at negative 27 degrees. Another example. Let's say now we got 1 newton up, 4 down, 5 left, and 3 right. So summing up the x's and the y's, we get 3 minus 5 minus 2, so 2 down. 1 minus 4 gives you minus 3, 3 down. Always start with the x, so you go 2 to the left and 3 down. Using the Pythagorean theorem, we get that the net force is the square root of 2 squared plus 3 squared, which gives you 3.61 newtons. The direction will be inverse tangent of 3 over 2 which gives you 56 degrees, but that's not the end, because 56 degrees is inside the triangle. But the angles in physics are always from the positive x-axis. So if you go all the way from the positive x-axis all the way to that angle, you're going to have to add 56 to 180, because the angle from here to there is 180. So you're going to have to add 56 to 180 to get 236. So the final answer is net force equals to 3.61 newtons at 236 degrees. How do you know the direction? Well, if the net force angle is like in this one right here, the angle is just from the x-axis, so that's pretty straightforward. If it's more like in this case, you're going to have to find the angle from here to there, right? So if you know what the angle is inside the triangle, you're going to have to do 180, which is from here to the x-axis in the negative direction. You're going to have to do 180 minus the angle inside to get this angle here outside, which is the direction of this vector. If you, for example, if you consider this as the direction, if you consider that as the direction, then you're going to have to remove the angle inside, so you can only have the angle outside. Now in the bottom example, if, let me see if I can do this, if we have the net force vector pointing this way, you're going to have to take the angle that is inside the triangle and add 180 so we can have the direction. And this right here was an example of an angle from the x-axis pointing the net force pointing this way. In the last example, we have the angle pointing down below the x-axis. So the angle, you take the negative of this angle and that gives you the direction. So these are the 4 cases involving the 4 quadrants in the coordinate system. My advice, always start with the x and then go to the y when drawing the net force vector. So here is a brief introduction on vectors. This is just the first video. Many more will. Hello everyone. In this video, I'm going to explain about the beginnings of trigonometry and right triangles, part 1. Right? The very basic introduction here as for a first video on the topic. So, a right triangle is a figure with 3 straight sides that are connected and with a 90-degree angle. Like you can see here, there's a 90-degree angle here. And the 3 angles inside the right triangle, they should add up to 180. This longer side is called the hypotenuse. Here I have shown an angle with a yellow line. There's also another angle there, but this side is the opposite side to this angle, and this side is the adjacent side to that angle. Now, some trigonometric identities that every high school students should know are the sine, cosine, and tangent. Pythagorean theorem states that the square root of x squared plus y squared gives you the hypotenuse. Trigonometric identities related to the right triangle is the sine of theta. Let's suppose theta is represented by this yellow line here. Sine of theta is the opposite of our hypotenuse. Cosine of theta is adjacent of our hypotenuse, and tangent of theta is opposite of our adjacent. Suppose we have the following triangle where we know the hypotenuse to be 10u, and the theta angle is 33 degrees, and here we got y and here we got x. Sine of 33 degrees will give us the opposite over the hypotenuse. Well, we do know the hypotenuse is 10. We just don't know what the opposite side is. But you can rearrange this equation by bringing the 10 over next to the sine, so y equals times sin of 33, which gives you 5.45 units. And same thing can be done with cosine of 33, where it's the adjacent over the hypotenuse. We know it's x over 10. We can rearrange this to find x, which gives us 10 cosine 33 equals 8.39 units. And we can use Pythagorean theorem to verify our work by doing the square roots of 8.39 square plus 5.45 square gives you 10 units. And you can also do inverse tangent to verify the answer. Inverse tangent of the y over the x, 5.45 over 8.39, which gives you 33 degrees, which means our answers have been checked. Suppose now we have the following triangle, where we know this side is 3 units and we know the angle is 20 degrees. We don't have the hypotenuse, neither do we have the adjacent side. Sine of 20 is 3 over the hypotenuse. So the hypotenuse then must be 3 over sine of 20, which gives us 8.77 units. And cosine of 20 gives us x over the hypotenuse. We know the hypotenuse is 8.77 units. So we bring the 8.77 to the next to the cosine, and we get that x is 8.24 units. Now we can verify our work if it's correct or not by doing the hypotenuse equals the square root of 3 squared plus 8.24 squared, and we do get 8.77, which is what we got for the hypotenuse to begin with. So that verifies our work, which checks. And inverse tangent, opposite over adjacent, 3 over 8.24 gives you 20 degrees, which means our answer is correct, because that 20 degrees matches with the 20 degrees in the figure. Now suppose we have this third example of a triangle in which now we have a 12 units for the hypotenuse, 3 units for the adjacent side, and y is the opposite side to this angle, right? So cosine of theta will give you 3 over 12, okay? Now, we can do inverse cosine of 3 over 12 to get the theta, because the inverse cosine does the opposite of the cosine. And we get 75.5 degrees for this theta. Then 12 cosine of 75.5 should equal 3 units, which it does, which confirms our solution. Then 12 sine of 75.5 gives you 11.6 units for the y. We can verify our work by doing the hypotenuse equals the square roots of x squared plus y squared. So 12, which is our hypotenuse, should equal the square root of 3 squared plus 11.6 squared, and in fact that is correct. And then if we once again check our work by doing the inverse tangent of 11.6 divided by 3, we also get 75.5 for the angle. So I've shown you guys 3 examples of right triangles, although in this one I forgot to say suppose and so forth. But 3 examples of triangles, how you find the missing angles and the missing sides, and also how to verify and check your work to see if it's consistent. And if you do the problem 1 or 2 and 3 ways, and if all 3 ways converges to the same answer, then you know you're in the right track. So this is an introduction, part 1 of trigonometry and right triangles. Thanks for watching.